this into 2 days maybe, all the sequence series review. So let's just first start with recursive formulas. Okay, these formulas are based on a previous term. They always have a sub n minus 1 in them. Okay, you also must include a sub 1. So I just want to make a note here. This is not given. You have to memorize this formula. Okay, so here's how it works. If it's arithmetic, obviously it means addition or subtraction, you state a sub 1, and then you state the rule. You take the previous term and subtract 5. So I subtract 5, subtract 5, subtract 5. So this is what they're looking for. State a sub 1, and then state the rule. If it's geometric, that means you multiplied. Remember, it's multiply only. Okay, so what are they multiplying to get from 3 to 4.5 to 6.75 to 10.125? They're multiplying by 1.5. So you state a sub 1, and then you state the previous term and what you did. You multiplied by 1.5. Every now and then, they'll throw one at you that is neither arithmetic nor geometric, meaning you got to kind of come up with your own pattern. So if I went from 2 to 5 to 11 to 23, my gut says I'm going to double that number and then add 1, it kind of looks like. 2 plus 2 is 4, or 2 times 2 is 4, plus 1 is 5, 5 times 2 is 10, plus 1 is 11, 11 times 2 is 22, plus 1. So again, you state the first term, and then you state the pattern that you found. Double the previous term, add 1. Okay, but anytime it says recursive, you have to have that a sub n minus 1 in there. So let's work out a few. It says identify if it's arithmetic, geometric, or neither, and then write a recursive formula for each. All right, so if I went from -4 to -6 to -8 to -10, what did we do to make that pattern happen? Subtract 2. So that means it's arithmetic. And we're subtracting 2. So to write a recursive sequence, we state a sub 1. A sub 1 is -4, meaning the first term. And then a sub n, so our general rule is take the previous term, a sub n minus 1, and subtract 4. Recursives are super easy. You just say take the previous term, and this is the pattern to follow. Take this term and subtract 4. Play with number 2. How do we go from 19 to 13 to 7 to 1? Sosha? Subtract 2. It would be subtracting 2, not 4. I had 4 in my head from here. It would be subtract 2. Yes. Sorry about that. Bless you. 19 to 13 to 7 to 1. What are we doing? Subtracting 6. So our difference is to subtract 6. So we state the first term, a sub 1 equals 19, and then the rule. A sub n is the rule. Then it takes the previous term, a sub n minus 1, and subtract 6. Simple. 25 to 75 to 225. What are we doing? Multiplying by 3. So now when we say multiply, we call that geometric. Okay, geometric. I forgot to write arithmetic here. I'm just in the go. Geometric. So this time it doesn't have a difference. It has a ratio, was what we multiply by. Our ratio is 3. So all we do is we state a sub 1. So in this case, a sub 1 is 25. And then our rule says take the previous term, a sub n minus 1, and multiply by 3. Sometimes in the multiple choice, they'll put the 3 in front. It doesn't matter. It still says times 3. Take the previous term, multiply by 3. Number 4, 3, 9, 27. Geometric, because we're multiplying. What are we multiplying by? 3. Multiplying by 3 again. So my ratio is 3. So again, to write a recursive, we're stating the first term and then the general rule. So take the previous term, multiply by 3. All right, -1, -4, -13. So subtract 3. If I subtract 3, am I going to get that pattern? It's definitely a neither. There's kind of a mix match. So how are we getting it? It's not just adding and it's not just multiplying. What are you thinking?
I was thinking times 3 then minus 1.
I think that works great. Times 3 and then minus 1. Let's see if it works. If I multiply this by 3, negative 1 times 3 is negative 3, and subtract 1, I get negative 4. That works. If I multiply this by negative 3, that's negative 12, and subtract 1, I get negative 13. That's awesome. All right, so a sub 1 is equal to negative 1. And then our rule says take the previous term, a sub n minus 1. You said multiply by 3, and then, I'm going to put that in parentheses, then subtract 1. I think that's perfect. Great find. Oh, Dree says it's not possible. All right, let's take... Oh, it's possible. You just couldn't figure it out. All right, 1, 5. So you're guessing it's not arithmetic or geometric. All right. Neither happening here. So let's see if you can figure out the pattern. I think I got it. See if you can figure out the pattern. I hear times 3 plus 2. Let's see if that works. 1 times 3 is 3, plus 2 is 5, so it worked there. 5 times 3 is 15, plus 2 is 17. 17 times 3 is 51, plus 2 would be 53. Yeah, that's perfect. So we're going to say a sub 1, nice work, equals 1. A sub n equals the previous term, a sub n minus 1, times 3, and then plus 2. All right, let's keep playing here. At her job, Monica earned $35,000 in her first year and receives a $1,500 raise each successive year. Write a recursive formula. So I want you to highlight that word. So every time you hear recursive, you're saying I need a sub 1 and the rule of the previous term. So what is a sub 1 here?
35,000.
Perfect. Okay. And my rule is we're going to take the previous year, so that's a sub n minus 1, and do what to it? Add 1,500. Every year we're just going to add $1,500 to the previous amount made. Good. And that's it. Okay, so recursive, state a sub 1, and then use the rule, the previous term and what we're doing. Number 8 just says state the first 5 terms of the sequence. So now I know it's recursive because it uses this a sub n minus 1. And I currently have a sub 1, and I want the first 5, so the next thing I would want to find is a sub 2. So I'm going to replace all these little n's with a 2. So then I really get 2 times a sub 2 minus 1 really just becomes a sub 1 plus 5. And what do we know a sub 1 is? A sub 1 is 2, so this becomes 2 times 2 plus 5, which is 9. So we got the first 5 terms. So the first term is 2, second term is 9. Now again, if it's multiple choice, no one sees that, right? If it's short answer, I would say this is probably fine here. I'm just kind of writing it out for anyone that's stuck.
What I do is I kind of just skip straight to the previous term.
Yeah, I agree with you. I'm just writing it out for anyone that's stuck. So a sub 3. So I'm going to replace all my n's with a 3. So I'm going to get 2 times a sub 3 minus 1 plus 5. So that's 2 times a sub 2 plus 5. A sub 2 was 9. 9 times 2 is 18, plus 5, 20, 23. And obviously, we would just keep going. So again, we're just multiplying by 2 and adding 5. Let's see if that pattern works. So if I go back to the first couple I've written out, if I multiply by 2 and add 5, I get 9. 2 times 2 is 4, plus 5 is 9. 9 times 2 is 18, plus 5 is 23. Can I just go off this pattern? 23 times 2 should be 23 times 2 plus 5 should get me 51. Times 2 plus 5 should get us 107. Okay, and we're just writing out that sequence using that recursive. All right, let's see what else they have here. Oh, the explicit formula. Okay. Now, so that was recursive. We're using that previous term. Explicit. These formulas, I just want to stress, are given to you on the exam. There's not much given, but this is the two that are. The arithmetic, and it's the explicit form, and the geometric, the explicit form. Okay, so you're not memorizing these two. They are given to you. I want to make a few more notes here about arithmetic. Okay, so make a note here for arithmetic. Arithmetic is unique because you're always adding the same amount, right? You're adding the same amount, which makes it a very unique function. This makes it a linear function. Okay, it will look like a line. Every arithmetic sequence will look like a line because you're adding the same amount, meaning the slopes are always the same. So what you really want to understand is that the difference that you find is the slope of the line. Okay, and that's the key in these. The difference is the slope. So it's just y2 minus y1 over x2 minus x1. Okay, in a linear function, the difference is the slope. If I skip down to geometric, okay, this time you're not adding the same amount, you are specifically multiplying by the same amount. Okay. This one has what we call the ratio, and if I were to graph this out, this will make an exponential function. And that is key. Make sure you get down exponential function. These are easy multiple choice questions they'll ask. They'll show you a linear graph, they'll show you an exponential, and they'll ask you which one's either arithmetic or geometric. Okay, so geometric will make an exponential function, arithmetic will make a linear function. Okay, and again, these formulas, they're on the formula sheet. So on our next test this week, I'll give you the formula sheet with it. Those are on there. So this says identify if the sequence is arithmetic or geometric, then write the explicit formula for each. Okay, we want the explicit formula. All right, so -2, 4, 10, 16. Am I adding or multiplying? Adding. So this is arithmetic. Let's put an A there. And what is our difference in this pattern? 6. Okay, so now you're going to go to your reference sheet and you're going to say, okay, we said it's adding. We're going to go to arithmetic. We're going to start with that formula. A sub n equals A sub 1 plus n minus 1 times d. And I'm not memorizing that. I'm just copying the formula down and plugging in what I know. I know A sub 1 is -2. And I know my difference is 6. You're always going to have an n because it's called A sub n. That's like your x in the problem. You always leave the n. And then you have to clean it up so it looks like a line. Order of operations, I can multiply the 6 times the n minus 1. So that's plus 6n minus 6. And if I put that together, I get 6n minus 8. And then I just want you to box in the slope. The slope is with the x. That slope is the difference. This is what makes it linear. The slope should be the same difference that we got here. That is what makes it linear. Try number 2. 4, 10, 25, 62.5. The moment I see a decimal, I know it's not arithmetic here. I went from a non-decimal to a decimal. Nope, that's recursive. Only on recursive, yeah. How are we getting from 4 to 10 to 25 to 62.5? What are we multiplying by? Good. So again, if it's not super obvious, right? What's the opposite of multiplication? Take these and divide backwards. A sub 3 divided by A sub 2. A sub 2 divided by A sub 1. We should get 2.5. Okay, so now I said it's geometric. It's multiplying. I'm going to go to the geometric formula on the reference table. Just copy it down. These are a lot easier. There's really nothing to clean up. A sub 1 ratio to the n minus 1. What is A sub 1 here? 4. And what did we just say the ratio is? 2.5, and everything has to have an n in it, raised to the n minus 1. Can I multiply the 4 and the 2.5 together?
No.
No, because the n minus 1 is only on the 2.5. Remember how we box in the base and exponent? Those are glued together. They're married. You can't break them apart. Stay together. All right, take a minute and go grab 3 and 4. Figure out whether it's arithmetic or geometric.
Is it possible to have an explicit formula for one that's not arithmetic or geometric?
Not in this course. We don't do that. Yeah. What did 3 turn out to be? Arithmetic or geometric? Arithmetic, super basic, right? You're just either adding or subtracting. And again, it's a3 minus a sub 2, a sub 2 minus a sub 1, if you're not sure, so you get the same thing. So that tells us it's arithmetic. The difference is 11. So again, I'm just going up and stealing the formula. A sub n equals a sub 1, so that's 14 plus n minus 1 times 11. If I clean that up, I should get 11n, what is that, plus 3? Does that sound right? Did I subtract wrong? Minus 11 and 14 should be 3.
Shouldn't it be -11?
Yeah.
Oh, Jiminy Crickets, it should be negative 11. I'm subtracting 11. How about negative 11? So that should be negative 11 plus 25.
Yeah.
You like that better? Sounds better. They tell you my contacts aren't on my eyes yet? I really can't see anything yet. All right, number 4. Now, if my number got smaller, would I be multiplying by a whole number or by a fraction? Definitely by a fraction, right? So clearly it's not arithmetic. So I'm going to do 7 divided by 21. 21 divided by 63. I should just get 1/3. So again, I'm just stealing the formula. A sub n equals a sub 1 ratio to the n minus 1. And I love geometric. There's nothing to clean up. You just write it down and it is what it is. Now, for the most part, when I go back and look, I think 85% are geometric. So they tend to lean towards geometric because it's exponential versus the linear. Number 5, Monica deposits 1 cent into a bank account on the first day of the month. What did they just tell you? A sub 1. How do you write 1 cent? 0.01, right? 0.1 would be 10 cents, 0.01. She then deposits 3 cents on the second day, so they just gave you a sub 2 is 0.03, and 9 cents on the third day, so a sub 3 would be 0.09. Oops, and they gave us one more. 27 cents on the fourth day. Assuming the pattern continues, write the explicit form. So you're saying explicit, given to me, I'm going to grab one from the table. I just have to figure out what it is. Is this arithmetic or geometric? Geometric. Our ratio is 3. Beautiful. So all I'm going to say is a sub n equals a sub 1 ratio to the n minus 1. Piece of cake. Okay, so recognize whether the pattern is adding or multiplying. Hopefully it's obvious. Again, if it's not, It's just a sub 4 divided by a sub 3, a sub 3 divided by a sub 2, etc. Okay, number 6. Given an arithmetic sequence of a sub 3 and a sub 7, determine the common difference. So here's the key. I'm going to go back to the notes we took. We started. We said if it's arithmetic, it's linear, and the difference is the same thing as finding the slope. All you're doing is finding the slope between 2 points when it says arithmetic. Okay, so my 2 points would be the third term is negative 9, and the 7th term is 7. And the difference equals the slope.
So would it be like,
Yeah, f of b minus f of a over b minus a. Excellent. 7 minus negative 9 all over 7 minus 3. Change in y over change in x. 7 minus negative 9 is actually a positive 16 over 4, which gets us a slope of 4 or a difference of 4. Okay, but because it's linear, the slope is the difference. You want to keep telling yourself that. Now, number 7, it's not as easy in number 7. Now they're telling you it's geometric. Okay, and they're giving us a sub 2 and a sub 6. Okay, so now because it's geometric, we kind of have to work this one out. So I'm going to go back to the geometric rule. A sub n equals a sub 1 r to the n minus 1. Let's jot it down. A sub n equals a sub 1 r to the n minus 1. Do we know a sub 1? No. All we know is a sub 2, so we're going to use a sub 2. So I'm going to call this a sub 2, which now means I'm replacing every little n with a 2. So I'm going to say a sub 1 r to the 2 minus 1. What do I know about a sub 2? I can replace that with a 6 equals a sub 1, and then this just becomes r to the first. Okay, and that's as far as I'm going to go there. I'm going to do the same thing with the second term. So I'm going to start with a sub n equals a sub 1 r to the n minus 1, the rule. And I'm going to say I can find a sub 6. That's about all I know here. A sub 6 equals a sub 1 ratio to the 6 minus 1. So I replaced all my n's with a 6. And then I know a sub 6 is 1536 equals a sub 1 r to the 5th. So now there's a couple different ways to go about it. They both have a sub 1, right? So I could solve each of these for a sub 1 and then just set them equal to each other because they both equal a sub 1. So I'm going to say 6 over r is equal to a sub 1, and 1536 over r to the 5th equals a sub 1. And if they both equal a sub 1, then they both have to be equal to each other. So 6 over r equals 1536 over r to the 5th. Then I would simply cross multiply 6r to the 5th equals 1536r. I can divide this r out of the way. I'm going to get r to the what here? R to the 4th, because when we divide, we subtract exponents. What else can I do with this 6? I can divide that over, so that's out of the way. 1536 divided by 6 is 256. And then what do I do to both sides? Fourth root it. Excellent. Fourth root. So use that calculator, unless you know the fourth root off the top of your head, which you certainly may. The fourth root of 256 should get us a ratio of 4. Okay, so you can always go back to those explicits. You could have done that for the the linear arithmetic one as well.
Would you get points off? Because what I did was I just went through numbers in my calculator and got that one down.
So if it was the show work section though, you got to put something down. Put something down. Don't just say I did this on my calculator. Like, start writing some math down for us. Rohan, same thing? Yeah, you know what I mean? Just like, you got to put something down on paper. Put something there. Yes. Okay, so as far as tonight goes, I'm going to do all the series tomorrow. series had a special formula that we were given, and then one we were not given. So I'm going to stick with series for tomorrow. Right now, we're going to talk about the tests from last week. So let me pass these out. I review test 1. And we're going to make corrections. That will be part of the homework tonight. I will try to give some points back, perhaps. They were making good corrections. We had a slight competition last period of spotted. And so should I think I have these here? I don't know. Just give me a second. Give me a nice one. Sosha, I don't know what I did here. Did I give it to you? No. Give me credits. I just had it here.
Shut up, Luke.
All right.